is our second video for OLI Mod 22. We're continuing with question 5, which goes along with a Learn by Doing activity in OLI on page 146. Our first question here is asking which of the following p-values will give the strongest evidence against the null hypothesis. So I'm a very visual person, so I'm going to go back to the visual here to just make sure we're all together. So we're assuming we have this normal SDSP, and in the center is whatever value our null hypothesis has given us for P. Now, remember that p-values are probabilities about getting our sample value result that we have or something more extreme. Let's just go ahead and pretend that our p-hat value happens to be to the right of center. It doesn't really matter, but let's pretend it's to the right. So a p-value of 0.31 would indicate an area outside that value of 0.31. So let's say that that area is 0.31. A smaller area of 0.14 would be if our value was over here. So now from here, our area outside would be 0.14, and then a p-value of 0.02, well, that's even smaller area. So maybe that would only be that tiny little bit out there. So as the areas get smaller, as the p-values get smaller, that possible location for our p-hat value moves further and further to the right. So the biggest evidence we have that this is not center, that HO is not correct, is the p-value falling furthest away from center, which then has the smallest p-value. So 0.02 gives the strongest evidence against HO. Tiny p-values mean unlikely events far from center have happened that make us not want to believe HO, that the center is here. Because remember, if I move this whole curve, if I move it over here, well, now all the p-values have changed. All the areas have changed. Okay, let's look at part B. If we are testing an alternative hypothesis, HA, P does not equal some number. Frankly, for this question, it doesn't matter what the alternative hypothesis is. Which of the following test statistics will give the smallest p-value? So test statistics talk about z-scores. They talk about how many standard deviations from center you are. So let's just think about this axis being scaled with our z-scores. So it would look something like that. So a test statistic of negative 0.5 would put something about there. A test statistic of 1.1 is about there. And a test statistic of -2 is there. Test statistic is the z-score of where your p-hat value is. Now, smallest p-value. P-value is the area outside of your value. So if my value was here, the p-value is that area. If my value is here, the p-value is all this area to the left. If my p-value is here, the p-value is all that area to the right. Which of those has the smallest area? This location here of -2. Last one. In 2008, the population of part-time college students was 60% female. So they're telling us population has a proportion of 0.6. So that's right at the center of the SDSP. We are curious if the proportion has decreased this year. So we're going to have possible sample values to the left. We're looking for a decrease. So alternate hypothesis that it's less. Which of the following p-hat values? So p-hat values means that it's a number along the horizontal axis here will give the smallest p-value. So let's kind of forget about scaling for a minute. I don't know where they'll be because we don't know what the standard deviation is here. But remember that p-value is area outside. So the value here that's going to have the smallest value outside has to be the smallest p-hat value. So if, oh, not negative, I didn't mean to write negative. It would have a negative, oh dear. Okay, so 0.4 is going to have the smallest area outside, which then means it has the smallest p-value because this is a number line. 0.48 would be further to center, and 0.56 would be further to center still. So the smallest p-value is going to be the p-hat that is furthest away from center, which is 0.4. So apparently all of the answers are the third choice. A smallest p-value gives you the strongest evidence to reject HO. A smallest p-value is whichever test statistic moves you further from center. So I just want to say here, you know, if there was choice 4, which was a positive 2.5, well, then that would be the value that gives you the smallest p-value, because 2.5 would be furthest from center, and so the area outside of that would be the smallest. Test statistic furthest from center gives you the smallest p-value. And in this case here, again, p-hat value furthest from center gives you the smallest p-value.